So let's read this given information. It says here, given the sum to n terms of an arithmetic sequence is Sn is equal to 3n squared minus 5n. And then the first question says, let's calculate the sum of the first 21 terms of this sequence for 2 marks. Okay, so we're given the sum of an arithmetic sequence. Okay, so this is not the general term, it is the sum. This is the summation formula. Alright, so we're asked to calculate the sum of the first 21 terms. So these are the keywords. Sum of the first 21 terms. So this is an easy 2 marks. We're simply going to substitute 21 into this formula because we're already given the summation formula. So it's going to be S. Wherever you see n, you're going to substitute 21 is equal to 3 times 21 all squared minus 5 times 21. And the sum of the first 21 terms, then you're going to use a calculator. You're supposed to get 3 times 21 all squared minus 5 times 21, 1218. So this is the answer to this question, which is the sum of the first 21 terms of this sequence. So remember, we still have the summation formula for this arithmetic sequence. Sn is equal to 3n squared minus 5n. So the second question says we should determine the 22nd term of this sequence for 2 marks. Now I'll try using a much simpler example so things can be easier for you. So let's just take a simple sequence, 1, 2, and 3. Okay. Now you can see that 1 is term 1, 2 is term 2, and 3 is term 3. You can see that. Alright. Now we should see that the sum of the first the sum of the first terms, it should be T1 because it's only one term, and T1 is actually 1. Okay. So the sum of the first terms is basically 1 in this sequence. And then the sum of the first two terms in the sequence, it's term 1 plus term 2. I hope you understand that part. The sum of the first 2 terms of the sequence, it's term 1 plus term 2. So S2 is equal to term 1 is 1 and term 2 is 2. Okay, and then the sum of the first 2 terms, you get 3. But now we should notice something. Remember, we said that term 1 is the same as the sum of the first terms of this sequence, which means if you're looking for a formula, you should know that S2 is equal to S1 plus term 2. Okay, because we said term 1 is the sum of the first terms. So it comes back to a formula which says term 2 is equal to S2 minus S1. Now this will be useful in answering the question. I'm trying to make you understand. This is not part of the solution. This is me explaining to you how we get this answer which says term 22, which is what I'm looking for, is equal to S22 minus S21. So this is the formula that we're going to be using, but I'm trying to explain how this formula comes about. So again, let's carry on below. We then have 1, or let's just look for S3. S3 is term 1 plus term 2 plus term 3. Okay, so S3 is equal to, we can see that term 1 plus term 2 is actually S2. And then term 3 is 3. Look at this properly. Term 1 plus term 2, we got the sum of the first 2 terms, which is this. And then S2 plus 3, okay, and then S3 3 is equal to the sum of the first two terms. We got it as 3, so it's 3 plus 3. So the sum of the first three terms is 6. So now there's a pattern that you should be aware of. So remember we said that 3 is term 3, which means S3 is equal to S2 plus term 3. And let's say we're looking for term 3. We're supposed to notice that term 3 is equal to the sum of the first three terms minus the sum of the first two terms. So it's also the same principle that applies, that the sum of the first 22 terms is going to be the same as the sum of, the term 22 is going to be the same as the sum of the first 22 terms minus the sum of the first 21 terms. Okay, so term 22 is equal to, let's substitute S22 into the formula and subtract with S21 from the previous question. So 3 times 22 all squared minus 5 times 22. Let's put that in big brackets. Minus, remember we got for S21 from the previous question was 1218. Now let's punch all of this into the calculator. The final answer that you're supposed to get after punching everything into the calculator, for the first large brackets, it's 1342 minus 1218. And then term 22 is basically going to be, using the calculator again, 124. So this is the value of the 22nd term. So 124. Now asked how many terms of this sequence must be added to obtain a sum of 8,162 for 4 marks, my mistake. So we are given the sum. Let's first substitute the sum into the formula. So it's 8,162 is equal to 3n squared minus 5n. And then we are asked how many terms of this sequence must be added to obtain this. So let's first write this in standard form. So this is going to be 0 is equal to 3n squared minus 5n minus 8,162. Now this actually looks familiar. There's something which is called our quadratic expression or equation, and in the standard form it's y is equal to an squared plus bn plus c, or some say ax squared plus bx plus c. Alright, and then we have something which we call our quadratic formula, which is normally x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. We're looking for x normally, but we're actually looking for n, because in this case we're dealing with n, which is the number of terms. So n is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So n is equal to negative b, negative 1 times b, in this case it's negative 5, plus minus the square root of negative 5 all squared minus 4. A, in this case it's positive 3, and then the c is negative 8,162. Close the brackets, all over 2, and then a is positive 3. We've now substituted everything. We can then do this on our calculator, but let's do it step by step. So n is equal to negative 1 times negative 5, that is positive 5, plus minus the square root of negative 5 all squared, that is 25, and then plus, I'm going to use a calculator again, so we're going to say 4 times 3 times 8,162, supposed to get 97944. The reason why it became plus is because negative times negative is positive, and then all over 2 times 3 is 6. Okay, and then n is equal to 5 plus minus the square root of 25 plus 9, 7, 9, 4, 4. That is 97,969 all over 6. And then n is equal to 5 plus the square root of that. The square root of 97969 is 313. So plus minus over 6. N is equal to 5 plus 313 over 6, or n is equal to 5 minus 313 over 6. Let's start with this part and see what we get. 313 plus 5 divided by 6. We get n is equal to 53. On this side, what do we get? 5 minus 313 all over 6. We get negative 51,33. Now here's the thing. N cannot be this one because we have a negative solution. And in dealing with terms, you can never ever have a negative term. You can have a negative value, but you can't have a negative term. You can't have term negative 3. There's no such thing as term negative 3. All starts from term 1, term 2, term 3, and so on. So n is equal to 53 is the final answer. So it says here, let's consider the sequence 7, 7, 7, 12, 7, 17, 7, 22, and it carries on. And then the question says, determine the value of the 78th term of the sequence for 2 marks. So it's only 2 marks. Now I'm pretty sure you're looking at all those 7s and 12s and thinking, how is this even a sequence? But let's further break it down. So it's 7, 7, 7, 12, 7, 17, 7, 22, and then it carries on. So we can see that this is actually term 1, the sequence. This is term 2 of the sequence. This is term 3 of the sequence. Term 4, term 5, term 6, term 7, term 8, and it carries on. Now, when looking at term 1 and term 2, nothing has changed. From term 2 to term 3, nothing has changed. But from term 3 to term 4, something has changed. Okay, when looking at term 2 and term 4, they're quite different. And when you look at term 4 and term 6, they're different. Term 6 and term 8, they're also different. Alright, now let's look at these two terms. Let's look at the sequence properly. We can see that there's actually 2 sequences in one. When you look at the odd numbers of the sequence, which is 1, 3, 5, 7, they're actually the same. It's still 7, 7, 7, 7. And then when you look at term 2, it's 7, and term 4, term 6, term 8 is 7, 12, 17, and then 22. So this is actually 2 sequences in one. So let's look at the first sequence, which says 7, 7, 7, 7, which is our term 1, term 3, term 5, and term 7. Now let's look at the remaining ones, which is term 2. We have 7. Term 4, we have 12. Term 6, we have 17. And then term 8, we have 22. So 7, 12, 17, 22. This is actually an arithmetic sequence. Because they actually have a common difference. When you take term 2, or the second term or whatever, which is 12, and you subtract it with 7, you get 5. When you take 17 and you subtract it with 12, you also get 5. So this actually forms an arithmetic sequence. And the arithmetic sequence says Tn is equal to A plus n minus 1 times D. So we're getting closer to the answer. Remember we said that this is term 2, term 4, term 6, term 8 of this sequence, but it actually forms a new sequence. So in this case, it's term 1 of the sequence, term 2 of the sequence, term 3 of the sequence, and term 4 of the sequence. So we have Tn is equal to A. Remember A is the first term, so it's 7 plus n minus 1 times, and then D, it's our common difference, so 5. Tn is equal to 7 plus n minus 1, 7 plus 5 times n, there is 5n, and then 5 times negative 1, that is negative 5. Tn is equal to 5n. 7 minus 5, that is 2. Positive 2. So we're getting closer to the solution. So what can we do from here? What we can do from here is we have to find the value of the 78th term. And how can we do that? So you can see this is actually broken down into two sequences. Term 1 of this sequence is the second term. And remember, since it's even numbers, so this is going to be a bit tricky. Since it's even numbers, the tricky part is it's going to be term 2, term 4, term 6, term 8. Term 78 is actually an even number, but it is actually the 39th term of this sequence. It is the 78th term of this sequence, but it's the 39th term of this sequence. So we're then going to say term 39 is equal to 5 times 39, we got the sequence, plus 2. So term 39 is equal to, using a calculator again, I'm going to take my calculator, I'm getting 197. So this is actually term 78 of this sequence, but it's term 39 of this sequence. Interesting question. So we're now asked to calculate the sum of the first 103 terms for 4 marks. And remember we said this is term 1, term 2, term 3, 4, 5, 6, 7, 8, and it carries on. So we're looking for the first 103 terms. Now when looking at this properly, remember it's an even, so it's an odd, even, odd, even, odd, even, odd, even. So that's how it goes. And when you carry on, it's actually going to be 52 odd numbers and 51 even numbers of the sequence. And when you add 52 and 51, you're supposed to get 103. Okay? And then so let's carry on from there. So with the odd numbers, which is the first term is odd, third term is odd, fifth odd term, seventh odd term, and so on. We can see that the odd terms, it's only 7. 7, 7, 7, 7. So it's basically going to be 52 times 7. We're going to add those 52 sevens, which is 52 times 7. We get 364. So you've solved the first part. Now we have to look for the sum of the 51 even numbers. So remember from the previous question we got the general term to be Tn is equal to 5n plus 2. Okay, and we said that A was 7, our common difference was 5. So we are now looking for the sum of the even numbers. Okay, so it's going to, we're going to use the formula Sn is equal to n over 2 into 2a plus n minus 1 times d. So the sum of the first 51 terms is equal to 51 over 2 into 2, remember A is 7, plus 51 minus 1 times our common difference is 5. Close the brackets. That's 51. If you punch all this into the calculator, you're supposed to get 6,732. So this stands for the sum of the 51 even numbers. But remember, we are looking for the sum of the first 103 terms of this entire sequence. We broke this down into 2 sequences. So what we can do from here, we basically have to take this 6732 and add it with the odd numbers, 364. Add it together at the end, you're supposed to get 7,096. So that is the final answer.